to the International Space Station's Expedition 42. This is Mission Control, Houston.
Hi, I'm Jim Cameron, Director of Avatar, and you're watching NASA TV.
Good morning from Mission Control Houston, and welcome to Space Station Live. It's Wednesday, January 14th, 2015. Joining us now here inside the International Space Station Flight Control Room in the Johnson Space Center in Houston, Texas. A little bit of unscheduled excitement for the crew of Expedition 42 today on board the International Space Station. Here to tell me a little bit more and update us on the current status, the program manager, Mr. Mike Suffredini. Mike, first off, thanks so much for joining me this morning. Really appreciate it. Busy time, obviously. If you could start us off, just kind of walk us through the genesis of what happened this morning.
Okay, I'll do that. This morning, about 4 a.m.
There you go.
There we go. This morning at about 4 a.m., the systems indicated to us on the ground that there were 4 measurements that indicated off scale. And at that time, the team didn't know what that was, what the cause of that was. And so one of those was what we refer to as accumulator quantity. It's basically the water level in one of the coolant loops inside the lab. And so this is important because we have a risk that we worry about, or at least protect against. And this has to do with getting ammonia into the crew environment. So the way we cool the space station is we have an ammonia system outside that transfers the heat from a water system inside, and the water system is inside to protect the crew. You don't want to have hazardous chemicals flowing through water loops. So we have heat exchangers where we exchange the heat between the water loop inside and the ammonia loop outside. So that's one location where ammonia can leak if you have a failure inside the heat exchanger, which they're designed to prevent. You could potentially leak ammonia because at higher pressure outside. You could leak ammonia into the water loop, and then there's a path through which it can find its way into the cabin. And so one of the telltale signs of a potential ammonia leak would be if the accumulator indicated you were filling up. And so this failure mode that we saw this morning, this alarm, indicated that the accumulator was filling up, amongst some other indications. But this was the one of biggest concern. And so the team, that was the beginning of a discussion about, are we dealing with a real ammonia leak into the water or not? Now, as everyone knows, ammonia is a very hazardous chemical, and so if this is possible, then we immediately safe the vehicle and get the crew in a safe place. So the way the station is designed, we have two main segments, if you will. We have the Russian segment, which houses the service module and the FGB and the ports associated with those two modules.
Okay.
And then there's an interface between that segment, the Russian segment, and the forward part of the space station called the U.S. operating segment. And that interface is at the node. And so for these kinds of emergencies, this specific emergency, we only have ammonia on the USOS side of the vehicle.
Okay.
The plan is to have the crew go into the Russian segment, close the node hatch, and then we have some steps to take. So they don their masks, they get into the Russian segment, they close the hatch, they do some Draeger tube testing, we call it, to look for ammonia in the atmosphere in the Russian segment, make sure that hasn't been contaminated. And then the team on the ground begins the process of trying to sort through the anomaly. So that's the steps we took because of the indications we had.
Okay.
Confusing things a little bit was we also saw an increase in pressure in the cabin. So if you're leaking ammonia into the water loop and it eventually finds its way into the cabin, then you would expect the cabin pressure to go up.
So that was another potential
So that's another
indicator.
cue, and those two cues together had the team really go into sort of a conservative mode to go protect the crew. So we did exactly that. We got the crew on the mast. They got into the Russian segment. They closed the hatch. We checked the environment. And since that time, we have been sorting through this anomaly. And in fact, we did it twice. Early on, we sent the crew in because we didn't have the confirming cue, at least not very solid. So we had the accumulator, but not really. The pressure wasn't changing dramatically. But we sent the crew to the Russian segment to be safe. Finally decided maybe this is just some sort of MDM problem because we lost so many measurements at one time. We let the crew come back into the U.S. lab, and then shortly after that, the pressure started to climb in the cabin. That's a confirming cue, and so then we went through the procedure. The crew donned the mask again and went back in the Russian segment and have been there ever since. The measurements on the Russian segment showed no indication. The crew is they don't have masks on. They're just in the Russian segment, doing the work that they can do while they're in there. And of course, we have all the CO2 removal, oxygen generation, food, all the things the crew needs. They have in the Russian segment, so they're safe there. Meanwhile, in the U.S. segment, the team has been working very hard to try to sort through the anomaly. At this point, the team does not believe we leaked ammonia.
Okay, so no hard evidence, no real indication so far that any ammonia was leaked.
What we are dealing with is this failure of probably a card inside of one of our multiplex or demultiplexers. It's just a computer that that sends telemetry down and brings commands back up, and this card has a number of measurements on it, and those were the measurements we lost. And through a source of how the systems reacted and what happens when you isolate the crew and shut off the ventilation and all the steps we take along the way, we power down systems. With quite a bit of things are done. We shut off the outside big pump, and we depress the big pump so it's not providing as much pressure to try to push ammonia into the cabin. Of course, that means we have to power things down. So a lot's going on, and we think there's something in that made the pressure change that was, that kind of gave the team a little bit of a question about at the time. Of course, it looked like no kidding pressure increase.
Yeah.
Now we're looking at thinking this may just be normal reactions to the events that started to unfold. So the team is working through that. We are now in a position where we think everything's good. But now we have this big road in front of us to get back reconfigured. So we've got the water loop up. We're as soon as we can get the MDM released, we've done data dumps and stuff of the MDM to know for certain the health of the MDM. As soon as we can release that to the ops team, then they will power cycle and see if we can recover these cards. That's important because we do want to get a look at the accumulator quantity before we bring the crew back in to the U.S. segment, just to be safe. So that step's in front of us. We're doing some power-ups now. We got quite a few systems up. Actually integrating the loop B, the external loop B, into the system is the most time-consuming one, because you can't just flip a switch and have ammonia flow through all the heat exchangers now, because of the conditions now you can freeze the heat exchanger, and for sure cause a crack, which would end up introducing ammonia into the system, and so that takes a little bit longer. So we have a couple steps in front of us. The first is to get the power-ups done, which the team is doing, or I should say one is to get the power-ups done that the team is working on. And the second then is to get insight into the accumulator to confirm that the system is tight like we believe it to be, and so we can bring the crew back into the U.S. segment. So that's where we are right now. We would like to get the crew back in the U.S. segment tonight.
Okay.
That would be our goal. While it's inconvenient for the crew to be in the Russian segment, it's certainly not unhealthy for them, and so we'll do due diligence to make sure we're comfortable with the environment before we send them in there.
Okay, so crew kind of hanging out in the Russian segment right now. Mission Control going to walk through powering up a bunch of systems just to make sure. So a couple of systems, obviously non-critical systems, powered down. Any impacts to science, things like that, on board the station with this event?
Well, there were two things we were trying to do today. One was get started with Micro 5, which was an experiment we were going to do in the microgravity sciences glove box, so people probably heard us getting configured ready to start that. So that's been delayed now.
Okay.
So the research has been all protected, and it's just we'll have to replan, result in any losses.
And one other thing I want to touch on real quick, so when the team saw the indicators, they snapped into action. It was all very quick when they made the decisions. Talk a little bit about, some of the different emergencies that we're trained for, not only the astronauts, but the teams on the ground, and kind of how important it is to get that training not only before flight, but also during flight. They're still training even while they're up there.
Right, and this is a really important aspect, because we don't have knock on wood, we haven't had any really major anomalies like this that cause us to get to the point where we're concerned about the crew's well-being and imminent well-being. And so, but we have three major categories of anomalies that can put us in an emergency situation. One is rapid depress, where you could get an impact or something that causes us to have a depress event. The other one is a tox issue, and of course ammonia falls under the tox issue, but there's other tox issues that can occur on board, but ammonia is the one that we trained the most for. And then finally is the fire and smoke issue. And so while fire and ammonia leaks are very, very, very low risk, all three of these types of anomalies we trained for on the ground in an integrated fashion with our Russian colleagues, with the crew, and then we actually practice them once we get on orbit to keep everybody sharp. These kinds of emergencies start with protecting the crew, then trying to deal with the issue, and then if in the end we can't deal with the issue, then some of them can result in evacuating the station. And so all of these steps have to be taken care of, and make sure the crew is real sharp and the team's real sharp, because if they occur, in some cases you have very little time to take the steps necessary to protect the crew. So this is something that we train regularly, and you could tell today the team, really there was never any risk to the crew. We were watching the data and trying not to isolate them, but we isolated them twice pretty fast. So if we need to do it, we know how to do it. The crew knows what to do. And in fact, after they isolated themselves in the Russian segment, Butch called down and said, "Hey, thought everything went really well. Everybody knew their jobs and got them down." And so we'll debrief that to see if there's any lessons learned. But it seemed like the team, as you would expect, reacted appropriately to the event.
All right. Well, good to hear. Happy words from the commander. Again, the crew safe inside the Russian segment, not in any danger. indicators pointing to no ammonia being leaked, but obviously the team here in Mission Control Houston and at the partner sites all over the world continuing to work through the issue. Mike, thanks so much for joining me, giving us the latest. Always appreciate it. And we will go back to Space Station Live now. And this is Mission Control Houston. Again, we just spoke with International Space Station Program Manager Mike Suffredini, giving us the latest updates on the potential ammonia leak now being pointed towards all the data not being an ammonia leak. Early indicators of the pressurized and a coolant loop water main, and also the atmospheric pressure starting to go up were obviously potential indicators of an ammonia leak, but as the teams here in Mission Control Houston continue to pore over the data, looking more like now a faulty sensor or a computer issue. So the crew, again, in absolutely no danger. They're safely inside the Russian segment right now, waiting for the teams down here on the ground to continue poring over the data and then giving them some go-ahead procedures, hopefully getting them back, opening up the full station, getting them over to the U.S. segment by later this evening. But obviously, safety first. The teams will continue to triple and quadruple check everything just to make sure before they give the go-ahead to reopen the hatches and reopen the entire station. So as we've talked about, the crew having an unexpected off day as they're inside the Russian segment as we continue to analyze the data from the alarm earlier this morning. Some of the science that they were scheduled to continue working on today that recently arrived on the SpaceX Dragon is going to be postponed for a little bit, but as Mike Suffredini indicated, no loss to science on board the station, just a slight delay. One of the newer labs that arrived at the International Space Station was filled with fruit flies, but obviously might be asking, why are we studying them when we already have humans in space? But one of the answers, fruit flies, a model organism used in many research studies, and we actually sent 225 flies up to the space station to study at the same time, where we can only send a couple of humans a year. Out at the Marshall Space Flight Center, our Lori Meggs visited the farm, if you will, which is located out at the Ames Research Center, to learn a little bit more about raising fruit flies for spaceflight.
Well, we're here down on the farm, but it's really not your average farm. I mean, there looks like 1 million fruit flies there. Is that what we're seeing? Tell us what we do here on the farm.
This is exactly what you're seeing. So this is where we breed the flies. So this is where we can get hundreds and hundreds of flies that we need when we do spaceflight experiments. And you know, if there's a scrub because of bad weather or something like that, and we have to fly the next day or the day after.
You have a couple of extra.
We have, yes, exactly. We have tons extra.
But these aren't the same. They're all different kinds, right?
Exactly. That's what I was going to say, is these are also all genetically all different. So even though to you they all look like bottles of flies, but these are genetically all different. And so let's say if there was one of these genetic lines that we were going to fly for space flight, we would take that and we would expand that stock to make many, many, many copies so that whenever we needed it, we were ready with young flies.
So to make copies, we've got to feed them, and that's what happens in here too.
Exactly, exactly. So this stuff here that you can see is the food. And so what, you know, as you can see, it's a lot of work. So what the team does is that they make the food. You have to give them food regularly. Unlike if you're working with, say, bacteria or yeast, you don't want to work with them for a while. You put them in the freezer and they're good to go. And then when you're ready, you come back and you revive them, right? You can't do that with flies. You have to constantly keep them alive and give them food till you're ready to use them. And then all these different genetic stocks are used for different kinds of experiments.
That's what I was going to say. How do you decide, okay, it's this jar that's going now or this bottle that's going now?
It's usually to do with the science question you're asking. So some of them, for example, may be important for studying how the heart functions. And so believe it or not, these flies have little hearts exactly like we do that beat and that have the same kind of regulation for the rhythm, for the heart rhythm. And so there are some mutants here where the fly heart function is altered, just like they would be in a human, in a family which had that particular mutation. Similarly, there are mutations for the immune system, so the immune function may be impaired. There's other kinds of mutations, for example, stress. So we have some called, they're long-lived flies, so there's this one that we love that's called Indy, which stands for I'm not dead yet, because those flies actually live almost twice as long as their counterpart without this particular gene change.
And that's usually 30 days, right? Their lifespan is
at least 30
short.
days, yeah. So once the adults come out, meaning that from the egg to the adult is about 10 to 12 days, and then once the adult comes out, they can live anywhere from 4 to 8 weeks, usually about 6 weeks. But then the long-lived mutants can live 2 months almost.
Wow. And I keep holding this, but
yes.
These are breathable. I mean, it's not sealed.
Exactly. So that's an excellent question. So yeah, these have actually living flies in them, as well as eggs, larvae, pupa, and the adults, which are all the life stages, and so they all need to breathe. And so these are cotton plugs. They're compressed cotton. So what's neat is they allow airflow back and forth very well, but yet they don't allow other infectious things or other bugs that you don't want in there to go in. So it's protective, but at the same time breathable.
So we grow flies here all the time?
We do. In fact, we have to have a continual stock going. And so all of these, and you can tell this would be too much work to do all in one day. And so basically the way we do it is, folks in the lab on a weekly basis have to feed. And mind you, what you're seeing here is only a subset. Inside these incubators, we have more flies as well. And so all of them need to be fed on a regular basis so they don't run out of food. And so that we're ready for space flight when we need to fly these fly knots up into space.
What is the one thing that we really have learned from studying fruit flies in space?
We've actually learned several things. One of them, just to give you an example from the last experiment, is that the immune system of the fruit fly is affected by spaceflight, which was not surprising in terms of we see that in humans and in other animals. We see indications of that. We also see that in flies. So then flies act as a good model to study the changes in the immune system in spaceflight. We also find that there are changes in stress, which again, happens to humans in space flight. As you can imagine, it's a pretty stressful environment. It happens to fruit flies as well. And so what we learned from looking at their physiology and their genetic changes after spaceflight is that there are these changes in oxidative stress. So you can study the mechanism by which the stress happens and what you can do to counter it with the flies. In the future, another thing, to give you an example, is a group of scientists, along with myself, but our collaborators, Rolf Bodmer, Karen Okor, Peter Lee, what we're looking at, we're also using the fly as a model to study cardiovascular function. So you can look at flies, look at heart function and how it's altered in space, and also have genetically engineered versions that have the same sorts of defects in heart function that the human population have. There are some mutants where, if a family has it in the human population, they're predisposed to heart problems. The flies have families like that too, and so we study those in the spaceflight context to understand, what are the alterations, what can you do to try and prevent those, and things like that.
What do fruit flies eat?
So fruit flies eat a mixture. It's a nutritious diet. There are two different kinds of diets that we have in the lab. There's this food that you see in the white color, and then there's another one that we're using that we use for a space flight that Shilpa was just working on, which is this blue color. We put this blue food dye in. But essentially it's a mixture. There's agar to kind of hold shape, but there's cornmeal, there's sugars like dextrose and stuff. There's some yeast, heat-killed yeast that we put in, to get proteins and vitamins and things like that. So it's a nutritious meal and a complete meal.
Not enough for me. I'm going to have to look in one of these refrigerators and see if there's anything else I can have for lunch. More flies.
And welcome back to Mission Control Houston. The actual Fruit Fly Lab 01 experiment involves 15 specialized fly cassettes, each one of those holding 15 flies, which means 225 flies have gone to the International Space Station. Fly farm at Ames used for a variety of experiments that are done both in space and on Earth. So again, if you're just tuning in for the end of Space Station Live today, very active day, both here inside of Mission Control Houston and on board the space station, as an alarm went off this morning shortly after 4 a.m. Eastern Time, 3 a.m. Central Time, indicating a potential ammonia leak. Since then, the crew has been inside of the Russian segment safely, not in any danger, while mission controllers continue to analyze all evidence pointing towards a faulty sensor. Again, no hard data indicating that any ammonia was introduced into the International Space Station atmosphere. But again, as we are moving towards the end of today's Space Station Live, a couple of quick programming notes for you. A little bit later this morning at 11 a.m. Central Time, 12 p.m. Eastern, I'll be bringing you a Distance Learning Network event. We'll be taking some questions from students from Bunker Hill Elementary in Middletown, Delaware, here inside of Mission Control Houston. And then tomorrow we will be having some briefings centered around the launch of Expedition 43, the launch of the 2 one-year crew members. That'll kick off with a overview and science briefing at 11 a.m. Central Time, 12 p.m. Eastern, where we'll hear from program officials, mission operations specialists, and science specialists to preview what's ahead for that mission. And then a little bit later in the afternoon will be the crew briefing itself, with NASA astronaut Scott Kelly and Russian cosmonauts Mikhail Kornienko and Gennady Padalka. That'll take place at 1 p.m. Central Time, 2 p.m. Eastern. All of that tomorrow, Thursday, January 15th on NASA TV. So as we close, again, to recap one final time, no ammonia detected to be introduced into the station atmosphere. Station crew safely inside of the Russian segment, while teams here in Mission Control Houston continue to analyze the events and build a forward plan to get them back inside with full use of the U.S. segment. For now, we'll go ahead and sign off. This is Mission Control Houston.